Good morning, my dear students. I, S. Muniraja, working as a assistant professor in the Department of Triple E. So I deal the subject high voltage direct current transmission, which is called HVDC transmission. So in Unit 1 contains introduction to HVDC transmission. HVDC transmission in introduction consists of technical and economical comparison of HVAC and HVDC transmission, types of DC links, power handling capabilities of HVDC lines, static conversion principles, static converter configuration. In Unit 2 consists of static power converter analysis, static power converters in 3 pulse, 6 pulse, 12 pulse converters, converter station and terminal equipment, commutation process, rectifier and inverter operation, equivalent circuit for rectifier, inverter and HVDC link, special features of converters. Unit 3 consists of control of HVDC converter system. How to control the HVDC? In Unit 3 consists of principles of DC link control, constant current, constant extinction angle and constant ignition angle control and voltage dependent current control, individual phase control and equidistant firing angle control. Unit 4 consists of harmonic and filters. Origin of harmonics in HVDC system, classification of harmonics and elimination of harmonics, suppression methods, harmonic instability problem, design of HVDC and AC, DC filters. In Unit 5 consists of transients, faults and protection of HVDC system. So in Unit 5 consists of origin of over voltage in HVDC system, over voltage due to DC and AC side line faults, converter faults, over current protection, valve group and DC line protection, over voltage protection of converters, surge arresters, etc. So, the entire course outcomes are after completion of course, the student should be able to compare HVDC and HVAC transmission system, understand the operation of various converters used in HVDC transmission system, devise mean to suppress and eliminate harmonics, design HVDC and AC filters. So Unit 1 Introduction to HVDC transmission. So the first topic is static conversion principles. Static conversion principles. In HVDC or high voltage direct current power system uses DC for transmission of bulk power over long distances. For long distances power transmission, HVDC lines are less expensive and losses are less as compared to AC transmission. It interconnects the networks that have different frequencies and characteristics. Compared to AC transmission, DC transmission have less number of conductors, so automatically the power losses are less. So the HVDC lines are less expensive. Why they said is HVDC need only two conductors. One is positive, another one is negative. But in AC transmission, we need a three conductors. That is a RYB. Whenever the number of conductor decreases, automatically that is a economical aspects. So and also another advantage of DC system is there is no frequency. Because of the absence of frequency we having number of advantages. The absence of frequency causes number of advantages. So overall, the AC is best better for generation and utilization. AC is better for generation and utilization. DC is better for transmission networks. So this is a summary. AC is better for generation and utilization. DC is better for transmission system. Please see this figure HVDC substation layout. So any layout we having sending end side and also receiving end side. Sending end side also have one converter station. The receiving end side also having another converter station. In between two converter station there is a overhead line. Please see the diagram. So this is a first power grid or network. This is HVDC transformer. This is converter which converts AC to DC. The DC is travels and again this is a inverter. So whatever the name is converter that will converts AC to DC or DC to AC. So this is a converts AC to DC. Second converter definitely converts DC to AC. How does HVDC transmission system work? In generating substation, AC power is generated which can be converted into DC by using rectifier. In HVDC substation, rectifiers and inverters are replaced at both end of the lines. The rectifier terminal changes the AC to DC while the inverter terminal converts DC to AC. The power remains the same at the sending end and receiving end of the line because this is a transmission system. So in transmission system, both ends of power, the sending end side power and the receiving end side power is same. DC is transmitted over long distances because it decreases the losses and improves the efficiency. A system having more than two converter stations and one transmission line is called two terminal DC system or a point to point system. Similarly, if substation has more than two converter stations and interconnecting DC terminal lines, it is called multi-terminal DC substation. So next one, another important topic is classifications of HVDC transmission system. The classifications of HVDC system depends upon the arrangement of the pole and the earth return. They are as follows: the monopolar link, bipolar link, homopolar link. The types of DC links are three types, that is a monopolar, bipolar, homopolar. By using these three configuration, we transmitted the DC power. So monopolar link. A monopolar link has only one conductor with ground or C as written path. Generally, the conductor has a negative polarity with respect to the earth. It uses one conductor. It is very advantageous because of one conductor the power loss is also less and the number of conductor decreases is a economical important point. The return path is provided by ground or water. The return path is provided by ground or water. Use of this system is mainly due to cost considerations. A metallic return may be used where earth resistivity is too high. This configuration type is the first step towards a bipolar link. This is the first step to go to the bipolar link. So this is a monopolar link. This will also having generating station. So this is AC power. This is converter 1 which converts AC to DC. This is converter 2 which converts DC to AC. This is a DC transmission line which having only one conductor. The monopolar link consists of only one conductor. Another conductor is we using earth or sea water is used for return path for conductor. Next one is a bipolar links. Have two conductors, one at the positive potential and the other at negative with the same magnitude with respect to the ground. At each terminal, two identical sets of converters are connected in series on the DC side. This is a bipolar link having two conductors. One is positive, another one used for the return path, that is a negative. One conductor is a positive terminal, another conductor is a negative terminal. In both the system, in both ends, there is a two converter stations, converter 1 and converter 2. Any DC links must consist of two converter stations. One is a rectifier, another one is inverter. Advantages: it uses two conductors, one positive and other negative. Each terminal has two converters of equal rated voltage connected series on the DC side. The junction between the converter is grounded. Current in the two poles are equal and there is no ground current. If one pole is isolated due to fault, the other pole can operate it with ground and carry off of the rated power. This is a very advantage for bipolar link. If one of the conductor is faulted or unhealthy, then another conductor will carry off of the rated load. Disadvantages: the terminal equipment cost is high, more conductor material is required, corona loss also high. Why the corona loss also high means? So in normally monopolar link having only one conductor, in bipolar link having two conductors. So the corona loss also high. Homopolar link has two or more conductors all having the same polarity and ground is used as return path. Please see the homopolar link. They having number of conductors, all the conductor 1, 2, 3, all the conductor having same polarity. Usually that is a negative. Why we use negative means the negative conductor having less corona loss compared to positive conductors. Normally compared to AC and DC, DC having less corona loss because of frequency options, and also the negative conductor having also less corona loss because this is a negative charge. It has two or more conductors all having the same polarity, usually negative. Since the corona effect in DC transmission lines is less for negative polarity, homopolar link is usually operated with negative polarity. The return path for such a system is through ground. Corona effect is less in negative polarity conductors. Less conductor material is required because ground is used as return path. We can avoid power interruption due to faults by transmitting power through other conductors. Reliability is high. Insulation costs are low in homopolar links. The disadvantages are ground return path causes corrosion of buried metallic structure. It causes disturbances in underground communication cables.